In this example, we are going to sketch a graph of the function 2 times sine of 3x minus pi minus 1. For this example, I'm going to demonstrate a concept known as a t-table in order to come up with the graph for this function. What that essentially implies is that I'm going to take values that I know are true for just sine of x, and then slowly take the adjustment or the changes that we have established from 2 sine of 3x minus pi minus 1 in order to come up with the new graph. First thing I am going to do, however, is I'm going to take the original function there and I'm going to factor out the number 3 from the inside, what we call the period change. That means I'm going to rewrite this function now as 2 times sine of 3x minus pi minus 1 as 2 sine of 3x minus pi over 3 minus 1. I then am going to create a t-table. With this t-table, I'm going to start in the middle with values of x and y, or I guess more accurately here, x and sine of x. And the values I'm going to use are the most convenient ones, which would be the quadrantal ones from the unit circle. So that means 0, pi halves, pi, 3 pi halves, and 2 pi. Of which sine of x, not this new function, the original just sine of x, has values at these 5 places at 0, 1, 0, -1, and 0. I then am going to take my changes to this function of sine and apply them to these coordinates. Note that I have left room on both the left and the right of my value of x as well as my values for sine of x. Let's start with the values for sine of x. With the values of sine of x, which are the y coordinates, I'm going to be doing the 2 changes to the y values, which are the amplitude and the vertical shift. And I'm going to do those in that particular order. You can think of it very similar to the order that mathematical operations are done. Typically, you do multiplication and division concepts before you do addition and subtraction. So amplitude, which is the number that is multiplying the function, I'm going to take care of first, and then I'm going to apply the vertical shift. The amplitude change here is multiplying the function by 2, and that is what I'm going to do to each of these coordinates. It's just multiply them by 2. Meaning I will now have, for the y coordinates, 0, 2, 0, -2, 0. Note that I'm not applying the amplitude change to the x coordinates. You can essentially think about this original line between x and sine of x as a barrier. The amplitude is affecting the y values, the result of sine of x. So I'm going to apply it just to the y values. I then will apply the vertical shift. The vertical shift is a subtraction of 1, and that's what I'm going to do. I'm going to subtract all values by 1. So that'll give me -1, +1, -1, -3, and -1. What I have now created at the end here, this last part of this table, these are my new y values. Once I get the new x values, I now have new x-y coordinate pairs. So let's now work on the x values. The y values were pretty direct. Basically, whatever operation you were doing is what I did to all the y coordinates. For the x values, it's actually more of the opposite. For example, the first thing I'm going to do to the x values is the period change. The period change is what I factored out of the inside of the function. However, that value of 3, which is multiplying on the inside, I am not going to multiply my new x values. What I'm going to do is actually divide. So I'm going to do the other operation, or the opposite operation. I will divide by 3 in this case. That will give me 0. Pi halves divided by 3 is pi over 6. Pi divided by 3 is pi over 3. 3 pi halves divided by 3 is pi over 2. And we get 2 pi over 3 for the last point. This function, by the way, has a period of 2 pi over 3. And if you now notice, my x values are going from 0 until 2 pi thirds is when it would start to repeat. So this does agree with the period of the function. The last change I'm going to do is I'm going to apply the phase shift. The phase shift is the value on the inside of this expression, the value that we are subtracting from x. For the phase shift here, kind of similar to the period change. The period change was multiplying, so we actually divided. Here I see a minus pi thirds here, so what I'm actually going to do is add pi thirds, because what we're doing is shifting this over to the right. This will give me pi thirds. Pi 6 plus pi thirds will give you pi halves. Pi thirds plus pi thirds will give you 2 pi thirds. Pi halves plus pi thirds will give you 5 pi 6. And 2 pi thirds plus pi thirds will simply give you pi. With this, I now have my new x values. If I pair these together, I now have x and y coordinate pairs. So let us start with the first coordinate pair. Pi thirds and -1. First I'm going to graph my value at pi thirds and -1, which puts my first point about there. After that, I have 2 pi, or pi halves, and +1. Pi halves is right between pi thirds and 2 pi thirds, so that would put our next point here. We then have 2 pi thirds and -1 is our third point. So that puts us back here. Our new baseline is at y equals -1. Then we have 5 pi 6 and -3. 5 pi 6 is right between 2 pi thirds and pi. That puts us down hereabouts. And lastly, we have pi and -1. That puts us back here. If you even just take a quick glance at the structure of these points, this does look a lot like what we're familiar with sine, which typically starts in the middle at the baseline or the midline and goes up, back down, and back up. This is doing the same kind of structure. Goes up from the midline, back down through the midline, and back up to the midline. What we now have done is sketched a graph for this function for one period. Remember that since it is periodic, this would repeat itself. So this graph would continue to make this same curve structure as we go for this. However, it simply asks us to make one full period. If you happen to use a different method that came up with a different section of this graph, but it is still correct, then that would still be okay, because you have sketched a graph of this for one period of it. But it does matter that you have at least one full period or one full cycle complete.